in cylindrical coordinate it is given x equal to r cos theta, y equal to r sin theta, and z equal to z, and we have to prove that Jacobian of x, y, z with respect to r theta z is equal to r. From the definition of Jacobian, we know Jacobian of x, y, z with respect to r theta z is equal to partial derivative of x, y, z with respect to partial derivative of x, y, z with respect to r theta z, and partial derivative of x, y, z with respect to r theta z can be written in determinant form. Partial derivative of x with respect to r, partial derivative of x with respect to theta, partial derivative of x with respect to z, then partial derivative of y with respect to r, partial derivative of y with respect to theta, partial derivative of y with respect to z, then partial derivative of z with respect to r, partial derivative of z with respect to theta, and partial derivative of z with respect to z. So if you find out the partial derivative of x with respect to r, it is given x equal to r cos theta. So partial derivative of x with respect to r will be equal to cos theta. So this is equal to cos theta. Partial derivative of x with respect to theta, that is equal to derivative of cos theta is minus sin theta. So partial derivative of x with respect to theta, if x equal to r cos theta, that is equal to minus r sin theta, and partial derivative of x with respect to z, if you find out partial derivative of x with respect to z, it will be equal to 0. So the third term will be equal to 0. Similarly, partial derivative of y with respect to r, if you find out the partial y is equal to r sin theta, so you find out partial derivative of y with respect to r, this will be equal to sin theta. So this is sin theta. Then partial derivative of y with respect to theta, if you find out the partial derivative of y, which is r sin theta with respect to theta, that is equal to r cos theta, and partial derivative of y with respect to z from this is equal to 0, and partial derivative of z with respect to r, z equal to z, so partial derivative of z with respect to r 0, partial derivative of z with respect to theta is equal to 0, and partial derivative of z with respect to z, that is equal to 1. So if you find out the determinant, if you calculate the determinant, then you have cos, from this column, this row and column, cos theta into r cos theta minus 0. So multiply r cos theta into 1. So r cos theta minus 0. 0 into 0, that is equal to 0. So from second term, minus r sin theta, and you multiply, you leave this column and this row. So 0 into 0, that is equal to 0. Sin theta into 1, so minus sin theta. And the third, for the third column, it is 0, so multiplication of 0 with the other terms, that is equal to 0. So you have cos theta into r cos theta minus 0 minus r sin theta into 0 minus r sin theta. This will be equal to r into cos theta into cos theta. So r into cos square theta plus, here minus and minus, plus r into sin theta, that is equal to sin square theta. So taking r common, cos square theta plus sin square theta, cos square theta plus sin square theta is equal to 1. So the answer will be equal to r. So in this way, you can find out the Jacobian of x, y, z with respect to r theta z, that is equal to r, where in the cylindrical coordinate it is given x equal to r cos theta, y equal to r sin theta, and z is equal to z. So in the next video, we will work out more problem how to convert from one coordinate system to other coordinate system using Jacobian. We will prove in the next video. Thank you.